Okay, this is question number 4. Here is the curve. I've got it here on my calculator. Find the slope, that is the gradient, of the tangent to x at x equals 1. Okay, so I can do analysis, sketch, tangent at 1. Okay, when I press XE, I get the equation, and the equation is minus 2x plus 4. Therefore, the slope is equal to negative 2. Alternatively, I could take this and take its derivative. And make x equal 1, and I get an answer of negative 2. Either way, I get the same answer. Find the obtuse angle that the tangent makes at x equals 1 with the positive direction horizontal x-axis. Okay, so I know that this looks like this. I'm looking for the obtuse angle, so I'm looking for that angle there. This is the acute, this is the obtuse, it's the obtuse that I want. So I know that the inverse tan of the gradient, so the inverse tan of negative 2, so if I take negative 2 and I use the inverse tan, trig inverse tan of negative 2, I'm wanting to the nearest degree. So if I put that into degrees, the nearest degree will give me negative 63. So that's negative 63. This here is 180 minus 63. So plus 180 gives me an answer of 116.5 or 117 degrees. Find the slope of the tangent makes a point P. Give your answer in terms of P. So if I come back up here and I put a P there, then my slope's going to be this in terms of P. So slope equals negative 4p squared minus 2 e to the 1 minus p squared. 1 mark, 1 mark, 1 mark, all 1 mark answers. So all they're wanting is the answer. So D part 1, find the value of P for which the tangent at x equals 1 and the tangent to x equals that are perpendicular to each other. So I know that this first one was y equals minus 2x plus 4. So its gradient is going to be negative 2. Looking at the one that's perpendicular, its gradient is going to be a half. So therefore, this value here, this slope that I had being the slope of my tangent at point P, is going to equal 0.5, and I'm going to solve that for P. And I'm looking at 0.655 as being my answer. So that's my answer to 3 decimal places. I've put my equation down, so make sure I get my method mark. Hence, find the coordinates of the point where the tangents of f at x equals 1 and x equals intersect when they are perpendicular. So I've got the line of minus 2x plus 4, and I'm going to have the line of the perpendicular at this value of p. So I'm going to copy that. Copy. I'm going to go, what am I going to do? I'm going to get expression, this is what I want, and I'm going to move that into, can I move that all the way down? Okay, I can copy this up from up here. Copy, paste, and now I'm going to copy this, copy, select this. I'd like to find the tan line, and at the point what P equaled, So that gives me an expression for that equation. I'm going to make that equal minus 2x plus 4, which is the equation of the other one. Execute, take my answer, solve for x. And that gives me x equals 0.8035. I want to find the coordinates, so 0.80 to 2 decimal places, and then I will take just the minus 2x plus 4, math 3 given x equals that, and that gives me a y value of 2.39295, 2.39, and that's not all. Okay, so now we have the two line segments connecting 0, FO, and 3, F3, and there's this other point in here, and N goes between 1 and 3. So N has to be in the middle, or in between. Okay, the first line segment connects a point to the point that, where that find the equation of this line segment in terms of N. Cool, so I'm assuming f of x is still whatever it used to be, 2x e to the and there it is there. Yep, okay, cool. So I've got a point which is n and 2n e to the 1 minus n squared. And I've got a point which is 0, 0. So my equation is going to be y equals the gradient. So that will be a rise of 2n e to the 1 minus n squared over n. So it's going to be 2 e to the 1 minus n squared x. Should be the equation of this straight line here. A second line segment connects Q to 3. Find the equation of this line in terms of n. Ah, golly. Okay, so I'm going to have is f of 3 equal to 0, I wonder? And the answer is no, it's not, because this is an asymptotic. So it looks as if it is, but it's not. Okay, so the gradient of this line should be y2, which is f of 3, minus y1, which is f of n, over x2, which is 3, minus x1, which is n. So that's going to be my gradient of this line. So my second line will be y minus f of 3 equals this gradient, which is f of 3 minus f of n over 3 minus n, x minus 3. I'm not going to write any more than that because that is correct. Doesn't have to be expanded or simplified in any other form. It didn't tell me to put it in the forms of y equals mx plus c, so I'm just going to leave it as that form. Okay, so I've placed this on my calculator and I'll show you what I did. So right up here, I've got from 0 to n of f of x minus my line, and that gave me this expression, which is the first area on the left. For the next one, I have defined my function, and then I've got my second line, which is this here, that gives me this. I've now gone the integral from n to 3 of that, minus f of x dx, to give me this. And this minus my first answer, solve for n, gives me two answers. And since n has to be between 1 and 3, I'm going to take the answer, which is 1.088, not 0.38.